Hi, good day, and I am Olive. First of all, Eid Mubarak to all of you. Today I have come with another episode of the newly discovered planet James Webb Telescope. Here we go. James Webb Space Telescope could determine if nearby exoplanet is habitable. A rocky exoplanet orbiting a red dwarf star 98 light-years away could hold the secret about how likely it is for planets like Earth to transform into inhospitable worlds like Venus. The exoplanet, named LP-899c, also known as Speculos 2c, was discovered in September 2022. It has a diameter 40% greater than Earth's and orbits its star every 8.5 Earth days at a distance of just 1.7 million miles, 2.8 million kilometers. The red dwarf, though, is small and cool, meaning that temperatures can be clement even close to the star. Indeed, LP-899c is located near the inner edge of the star's habitable zone, which describes the distance around a star where a planet with an Earth-like atmosphere can support liquid water on its surface. December 25, 2021 at 5:20 p.m. NASA's James Webb Space Telescope, the agency's successor to the famous Hubble telescope, launched on December 25, 2021 on a mission to study the earliest stars and peer back farther into the universe's past than ever before. New research led by Lisa Kaltenegger, director of the Carl Sagan Institute at Cornell University, has modeled the possible climatic and atmospheric states that LP-899c could be in, and how the James Webb Space Telescope could distinguish between them. LP-899c's position in its planetary system is analogous to Venus's location in our solar system, which is also at the inner edge of the habitable zone. In principle, a planet at Venus's location can remain habitable, but at some point in its 4.5 billion-year history, Venus got trapped within the feedback loop of a runaway greenhouse effect. Any water Venus once had on its surface boiled away, and the planet was left with a thick carbon dioxide atmosphere. However, not all planets on the inner edge of the habitable zone will necessarily evolve the same way that Venus has. For one, Venus does not have its own magnetic field to ward off the solar wind, the stream of charged particles flowing from the sun. This made it easier for the solar wind to carry away hydrogen atoms that were split from water molecules by ultraviolet light from the sun, thus depleting the planet of water. If LP-899c has a strong magnetic field, it may be able to ward off its star's stellar wind and hold onto the water vapor in its atmosphere. Looking at this planet will tell us what's happening on the inner edge of the habitable zone. How long a rocky planet can maintain habitability when it starts to get hot, Kaltenegger said in a statement. Kaltenegger's team modeled the planet based on its mass and radius, both of which astronomers have measured. The models also incorporated assumptions about the planet's chemical makeup, its surface temperature and pressure, the depth of its atmosphere and the amount of cloud present. These latter factors are currently unknown. Indeed, the planet could be airless and cratered for all we know, which a strong possibility is given that red dwarfs are often prone to violent flares that could strip an atmosphere from a nearby orbiting world. The team produced 5 different models describing what LP-899c might be like. These ranged from an Earth-like planet but hotter, through various degrees of atmospheric water vapor content and levels of greenhouse effects, culminating in the final model resembling hellish Venus with its suffocating carbon dioxide. A separate study, led by Jonathan Gomez Barrientos of the California Institute of Technology, shows that JWST would only need to observe 3 transits of LP-899c across the face of its host star to confirm a steamy, water-rich atmosphere. 8 transits to gather enough data to determine whether LP-899c is more like Venus, and 20 transits to find evidence of the still habitable hot Earth scenario. Since the planet transits its star every 8.5 Earth days, the measurements could in principle take just 6 months to make. This planet is the first target where we can test these different scenarios, said Kaltenegger. If it's still a hotter Earth, hot, but with liquid water and conditions for life, then the inner edge of the habitable zone, around all stars, could be teeming with life. JWST cannot directly detect water on the planet's surface, but it could determine whether the atmosphere's composition would suit the presence of liquid water. Even if LP 890-9c turns out to be too hot for life, the findings could teach us about the fate of our own planet, Earth. As the sun ages, it will steadily grow brighter and warmer. Within about 1 billion years' time it will have made Earth too hot for life to survive, and the oceans will evaporate. Studying a planet other than Venus that has already gone through this phase, or perhaps even resisted it for now, will help inform us about Earth's own future. It will teach us something fundamental about how rocky planets evolve with increasing starlight and about what will one day happen to us and Earth, said Kaltenegger. Lisa Kaltenegger is an Austrian world-leading astronomer with expertise in the modeling and characterization of exoplanets and the search for life. I hope you liked the article. Here is some glossary for you to know the meanings of difficult words and terminology used. Inhospitable, sad face. Of an environment, harsh and difficult to live in. The inhospitable landscape. Analogous. Comparable in certain respects, typically in a way which makes clearer the nature of the things compared. They saw the relationship between a ruler and his subjects as analogous to that of father and children. Habitable zone is the distance from a star at which liquid water could exist on orbiting planets' surfaces. Habitable zones are also known as Goldilocks zones, where conditions might be just right, neither too hot nor too cold for life. Ward off. Prevent someone or something from harming or affecting one. She put up a hand as if to ward him off. Stream of charged particles. An electric current is a flow of charged particles, such as electrons or ions, moving through an electrical conductor or space. It is defined as the net rate of flow of electric charge through a surface. Ultraviolet light. Ultraviolet, UV, is a form of electromagnetic radiation with wavelength shorter than that of visible light, but longer than X-rays. UV radiation is present. Stars. Stellar. Stars are grouped into 7 main categories, also called classes. These were created by astronomer Annie Jump Cannon. The classes are called O, B, A, F, G, K and M. Stars in the O class are the most massive and hottest. Stars in the M class are the smallest and coolest. Cratered. Of the ground or a planet, having large bowl-shaped cavities in the surface. The cratered surface of the Moon shows it has a history of violent collisions with asteroids. Red dwarfs. A red dwarf is the smallest and coolest kind of star on the main sequence. Red dwarfs are by far the most common type of star in the Milky Way. List of red dwarfs. Habitability of red dwarf systems. Prone to. Likely or liable to suffer from, do, or experience something unpleasant or regrettable. Farmed fish are prone to disease. Violent flares. According to NASA, solar flares are powerful bursts of energy on the sun. They occur in sunspots when magnetic energy is released. They appear as bright areas on the sun. A solar flare can last mere minutes or take place over several hours. Hellish. Of or like hell. An unearthly, hellish landscape. Teeming with. To be full of life and activity. To have many people or animals moving around inside. Thanks for watching. Please subscribe, share and comments. Stay connected for more updates.